Okay, so get this. You know how we're always talking about energy efficiency and making our devices last longer?
Hmm.
Well, what if I told you that erasing data, just hitting that delete button, is actually one of the biggest energy hogs in our computers?
It sounds crazy, but it's true.
It is. I was reading this fascinating article in IE Spectrum about a company called Vaire Computing, and they're trying to completely flip the script when it comes to energy and computing.
Yeah, they're really tackling a fundamental problem that most people don't even think about.
Right, like who knew that just deleting a file actually generates heat and that heat is just wasted energy?
Exactly. Vaire is challenging this assumption that energy loss is just an inevitable part of computing.
So instead of trying to make our current computers sip energy more slowly, they're basically saying, hold on, what if we could recover the energy used in computation?
It's a radical idea, right?
It is, and it's where this whole mind-bending concept of reversible computing comes in.
Yeah, exactly. Think about it this way. Traditional computing is like a one-way street. You perform a calculation, you burn some energy, and that's it. Gone.
Like a car burning gas, you can't get it back.
Precisely. But reversible computing wants to create a round trip where you can essentially uncompute the calculation and recover that energy.
I'm trying to wrap my head around
I
this.
know it's a lot to take in.
The article mentioned an analogy to a swinging pendulum.
Ah, yes. The pendulum is a great way to visualize this. You see, a pendulum swings back and forth, constantly exchanging energy between potential and kinetic energy. But the total energy within the system remains constant.
Okay, so there's no energy being lost, it's just changing forms.
Exactly. Reversible computing aims to apply those same principles, embedding circuits in tiny resonators that oscillate back and forth, minimizing energy loss during computation.
So are they basically building tiny pendulums on a chip?
Well, not exactly pendulums, but the concept is similar. These resonators are designed to store and release energy in a highly controlled way, allowing for computation to happen with minimal energy loss.
This all sounds incredibly complex. Who are the people behind Vaire Computing, and what makes them think they can pull this off?
The key figure is Michael Frank. He's a researcher who's dedicated his entire career to this idea of reversible computing and co-founded Vaire back in 2024.
So this wasn't some overnight inspiration.
No, not at all. Frank has been working on this for decades, just waiting for the right moment.
Why now, though? What's changed?
Well, there are two major things happening right now that make this the perfect time for reversible computing. First, you've got Moore's law, which basically predicted the exponential growth of computing power, but it's hitting a wall.
We're reaching the physical limits of how small we can make transistors, right?
Exactly. We can't just keep making things smaller forever. We need new ways to improve performance.
So the old tricks aren't working anymore.
Right. And that brings us to the second factor. The demand for computing power is just exploding. Think about it. Data centers, artificial intelligence, cryptocurrency mining,
They're all energy-hungry beasts?
they are. It's clear that we need a new paradigm if we want to keep up with the demands of the future, and Frank believes that reversible computing is the answer.
He's actually claiming that reversible computing could offer something like a 4,000x improvement in energy efficiency. That's a pretty bold statement. What makes him so confident?
It definitely is ambitious, but the key is in how reversible computing fundamentally changes the way we think about energy use. Instead of constantly losing energy as heat, Vaire's approach allows for the recovery and reuse of energy within the system.
So it's not just about making our current computers a bit better. They're talking about a completely different way of doing things.
Exactly.
But how realistic is all of this? Can they actually build computers that work this way?
Well, that's the million-dollar question, right? Their approach is to integrate their reversible technology into existing CMOS technology, which is what most computers today are based on.
Why not just start from scratch and build a whole new type of computer? Wouldn't that be easier?
Starting from scratch would be incredibly difficult and expensive. By integrating with CMOS, they can leverage all the advancements in chip manufacturing that we've made over decades and just focus on developing the specific components needed for reversible computing.
So it's like building a hybrid car. You're combining the best of both worlds.
Precisely.
Okay, that makes sense. But I'm guessing this integration is not exactly a walk in the park.
You are absolutely right. Building these resonators on a chip, making sure they can talk to traditional transistors, and designing the software to manage this new kind of computation is, well, it's a monumental task.
So we left off talking about how Vaire is trying to basically stitch this radical new technology into the fabric of our existing computers.
Yeah, it's a bit like trying to teach an old dog new tricks.
Yeah. It is. How do you make something that's inherently non-reversible? Well, reversible.
It's a brilliant but challenging feat of engineering.
Yeah.
You see, the way traditional CMOS transistors work is like flipping a light switch on and off.
Okay.
There's a sudden jolt of energy each time.
Right.
But Vaire is tackling this by employing something called adiabatic switching.
Adiabatic switching.
Yeah, it's a much gentler approach.
Okay.
Imagine slowly dimming a light instead of abruptly switching it.
Okay, so it's all about making those transitions smoother and minimizing the wasted energy.
Exactly.
But even if the switching is gradual, doesn't it still take some energy to actually change the state of the transistor?
It does, but here's where it gets really ingenious.
Okay.
Vaire is embedding their circuits within these tiny structures called resonators.
Resonators.
And understand this, think of a child on a swing.
Okay.
As they swing back and forth, their energy is constantly shifting between potential energy at the peak of the swing and kinetic energy as they rush through the bottom. However, the total energy within the system stays relatively constant.
So they're harnessing this natural back and forth flow of energy to power the computation.
Precisely. The voltage in the resonator oscillates up and down, much like the swinging motion.
Okay.
And this oscillation drives the reversible computation.
I see.
When the computation is reversed or uncomputed, the energy is fed back into the resonator, almost like recapturing the energy of the swing.
That's amazing. But building these resonators on a chip, especially at such a tiny scale, it just sounds incredibly challenging.
Oh, it absolutely is.
What are some of the hurdles they're facing?
One of the primary challenges is crafting these resonators with incredible precision.
Right.
The first prototype chip that Vaire is developing uses something called an inductive capacitive resonator, or LC resonator.
LC resonator.
Yeah.
Okay.
It's a relatively simple design.
Okay.
But even so, it's pushing the limits of current fabrication techniques.
Right.
They need to ensure that each component is perfectly formed and integrated to minimize energy loss.
So what can this first chip actually do? Is it ready to, run complex AI programs?
Not quite yet.
Okay.
Think of it as a baby step,
Okay.
a demonstration that their concept actually works.
Okay.
This first chip is designed to perform a very basic arithmetic operation.
Addition.
Addition,
Right.
yeah, just adding numbers.
So it's laying the groundwork for more complex operations in the future.
Exactly.
What's next on their roadmap?
They're moving full steam ahead.
Okay.
They're already working on a second chip,
Okay.
slated for release in 2027,
Okay.
which will be specifically designed for AI inference.
So that's a much more complex task than just adding numbers.
Oh, absolutely.
Yeah.
And it requires much more sophisticated resonators.
It seems like they're putting a lot of their focus on AI applications.
They are.
Why is that?
Well, AI is one of the most computationally demanding and energy-hungry fields today.
Right.
If Vaire can demonstrate that their technology can improve AI efficiency,
Yeah.
it would be a huge validation of their approach and could pave the way for widespread adoption.
That makes sense. But they're also aiming for, this truly massive improvement in energy efficiency.
Yeah.
Something like 4,000 times better than what we have now.
It's a very ambitious goal.
What are some of the biggest obstacles standing in their way?
Well, that 4000x figure is a theoretical target based on perfectly efficient reversible computation.
Right.
One of the key factors influencing this efficiency is the quality factor of the resonators.
Okay, quality factor, what does that mean exactly?
It sounds like something you'd see on a nutrition label, right?
It does.
Well, in essence, the quality factor is a measure of how effectively the resonator can store and release energy without losing it as heat.
Okay.
A high-quality factor means very little energy is wasted, which is what we want for reversible computing.
Got it.
Imagine a bell that rings for a long time after being struck. It is a high-quality factor.
Okay, so the higher the quality factor, the closer they get to that 4,000x improvement.
Exactly.
But the LC resonators in the first prototype,
Yeah,
they have a relatively low quality factor.
that's right.
Yeah.
Which is why they're not expecting to achieve that full potential energy saving right away.
So how do they plan to improve the quality factor then?
They're exploring several avenues.
Yeah.
One promising approach involves using something called microelectromechanical systems, or MEMS, to create the resonators.
Okay.
These are tiny mechanical structures that can vibrate at incredibly high frequencies
Wow.
with minimal energy loss.
So they're not just putting all their eggs in one basket.
No, not at all. They're experimenting with different designs to see what works best.
Right.
And remember, it's not just about the hardware.
Right.
They also need to develop new software tools
Yeah.
that can actually design and program these reversible computers.
Right, because all of our current programming languages and tools are built for traditional computing.
Exactly. It's a whole new way of thinking about computation.
Yeah.
Vaire is investing heavily in developing new design automation tools and programming languages specifically tailored for reversible logic.
So they're creating a whole new ecosystem for this technology.
They are. It's like they're not just building a new engine.
Right.
They're redesigning the entire car.
But even if they overcome all of these technical challenges, how do they plan to get people to actually use reversible computers?
That's the big question, right?
Will people even want them?
That's the crucial question.
Yeah.
Ultimately, the success of this technology hinges on whether it delivers tangible benefits.
Right.
Benefits that outweigh the costs and the learning curve of switching to a new paradigm.
Yeah.
But if Vaire can demonstrate even a fraction of the energy savings they're aiming for,
Yeah.
I think the market will take notice.
I mean, who wouldn't want a smartphone that lasts for weeks on a single charge?
Exactly.
Or a data center that uses a fraction of the electricity?
Precisely, the potential benefits are enormous,
Yeah.
both for individual consumers and for the environment as a whole.
Welcome back for the final part of our deep dive into this world of reversible computing. We've gone from, the basics of how our computers use energy to how this company Vaire is trying to completely change the game with computation. So, let's zoom out a bit, the big picture. What could this mean for the future? Not just, faster phones, but the whole shebang.
Yeah, that's what makes this so exciting. This isn't just about making things a little bit better.
Yeah.
It could potentially disrupt entire industries.
Wow.
And even offer solutions to some really big problems that we're facing globally.
One thing that comes to mind is artificial intelligence.
Right.
Everyone's talking about AI these days. It uses so much energy.
It does.
Could reversible computing be the key to making AI more sustainable?
It's definitely a possibility.
Yeah.
Think about it. Right now, training a large AI model can have the same carbon footprint as a small town.
It's crazy.
Just from the sheer amount of computation. But if reversible computing could deliver even a fraction of that 4,000x energy efficiency that Vaire is aiming for,
Right.
the impact could be huge.
So not just greener AI, but also potentially more affordable AI, right?
Exactly.
That could open up the field to smaller companies and researchers who don't have the resources to build those giant data centers.
Exactly. It could really democratize AI development,
Yeah.
lead to more innovation,
Right.
a wider range of applications being explored.
And speaking of data centers,
Yeah.
they are massive energy consumers.
Huge.
We're talking about server farms the size of football fields that constantly need to be cooled.
Yeah, it's mind-boggling.
Could reversible computing make a dent in that problem?
Absolutely. The potential is enormous.
Yeah.
Imagine data centers that require just a fraction of the electricity and
Right,
cooling
yeah.
they do today.
That would be amazing.
It's not just good for the bottom line.
Right.
It's a significant step towards a greener internet.
So cheaper cloud services?
Right.
A lighter environmental footprint?
Exactly.
It's a win-win situation. Yeah. But what about our own personal devices,
Oh, yeah.
What would reversible computing mean for, the everyday technology that we use?
This is where it gets really tangible for people.
Right.
Imagine a smartphone that lasts for weeks on a single charge,
Oh, wow.
or a laptop that can power through days of work without needing to be plugged in.
I mean, I'm so tired of being tethered to a power outlet.
I know, right?
They would be life-changing.
We would.
And wouldn't that mean we're producing fewer batteries?
It would.
Which is also good for the environment.
Absolutely. It's not just about convenience.
Right.
It's about reducing our reliance on a technology
Yeah.
that comes with its own environmental costs.
Right.
Reversible computing could lead to a more sustainable, eco-friendly tech landscape.
It's a really compelling vision of the future, but
Yeah.
let's be honest, we're still in the early days here.
We are.
There are some major technical challenges, and it could be years or even decades before we really see reversible computing everywhere.
It's true.
It's important to be realistic.
Yeah, this is not a quick fix.
Right.
This is a long-term goal.
Yeah.
But I think it's so crucial to invest in these kinds of really radical innovations,
Right.
even if the payoff is way down the road.
Because even if, this specific technology doesn't work out exactly as they envision it, the research and development that goes into it could lead to other breakthroughs, right?
It's the beauty of scientific exploration, isn't it?
It is.
We're pushing the boundaries of what's possible.
Yeah.
Even if we take a few detours along the way,
Right.
we're bound to discover something valuable.
So as we're wrapping up our deep dive on reversible computing, what's the one key takeaway you want our listeners to walk away with?
I think the most important message is that the future of computing is not set in stone.
Yeah.
It's up to us as a society to decide what direction we want to take. And by exploring these different paths, these alternative paradigms like reversible computing,
Yeah.
we open up the possibility of a future where technology is both powerful and sustainable.
That's a great note to end on.
Yeah,
We've explored the potential of this pretty mind-blowing technology from the nitty-gritty technical details to the wider impact on our world.
it's been quite a journey.
It has. And it's a good reminder that sometimes the most exciting innovations come from challenging our assumptions and really daring to think differently.
And who knows, maybe one of our listeners will be inspired to contribute to this field
Right.
and help bring this vision of a more sustainable future to life.
Well, on that note of possibility, we'll wrap up this episode of The Deep Dive. Keep those minds curious and those pendulums swinging.